Jupiter is the largest planet in our solar system. It is visible with the naked eye, and the banded cloud structure can easily be seen with a small telescope. Those clouds have contained a mystery that has baffled scientists. A newly released image may provide a piece of this puzzle. The weather on Jupiter is so different from that on Earth that astronomers have struggled to understand it. A newly released infrared image may provide an additional piece in this puzzle. When we look at the clouds on Jupiter, we can see that there are dark and bright clouds. When these clouds are examined in infrared, it appeared that the darker clouds were the brightest in the infrared image. This, they believe, is because these are areas of thinner cloud, allowing the heat from Jupiter's interior to shine in the infrared images. In the visible light image, it is not possible to distinguish between thin cloud cover and the thicker cloud cover. They even managed to add in some flyby data from the Juno probe, and this detected atmospheric radio signals from powerful lightning strikes. These were all clustered around the poles of Jupiter. This is the opposite of what we find here on Earth, where lightning storms are generally found to be more common around the equator. Here, the planetary scientists believe that this difference is due to how the Sun warms both the planets. In both cases, the equator is warmed more by the Sun. On Earth, this generates convection currents that drive tropical storms. On Jupiter, they speculate that the distance causes this warming to be milder, and therefore this warmth never reaches the poles. What they found was that lightning strikes were generated in regions with large convective towers of moist air over deep clouds of water. Clear regions around these storms are probably caused by a downwelling of drier air outside the convection cell. Now, I find this odd. The Sun's heat is not as strong at Jupiter, but the most is received at the equator. This heating only affects the upper atmosphere, yet at the poles there is less heating, yet more electrical activity. Let's just take a step back here. Let's start with an alternative idea of why we see more electrical activity at the poles. Io plays an important role. It is close enough to Jupiter to feel a huge flexing due to the gravitational effects. This causes huge volcanic eruptions. This ejected material leaves Io and quickly becomes ionized. Once ionized, it follows the magnetic field lines and forms a vast torus around Jupiter called the Io torus. As Io's atmosphere is highly ionized, its movement through the magnetic field lines of Jupiter will have a dramatic effect on these emissions. As Io moves through the magnetic field, a current will be induced. As Io sweeps past and generates this current, it actually disturbs the magnetic field of Jupiter, and this can last for some time after it has passed. This electric current carries several million amps and has a potential difference of 400,000 volts. Jupiter's auroras are about 100 to 1,000 times stronger than those on Earth. They are so powerful that they actually emit synchrotron radiation. Jupiter is the only planet in the solar system that does this. Could the inflow of material along the magnetic field lines, coupled with a huge potential difference, drive electrical activity in the polar regions? Now let's just briefly talk about the infrared images. Their concept of thinner clouds equals brighter images at first seems the most likely explanation. The only slight odd thing is, why are these clouds always darker? Now, it could be that the clouds at these lower altitudes just happen to contain more darker coloured materials. When we examine the image of the storm, again I noticed something a little odd. This could be just because I'm making assumptions based on storms here on Earth, but at the moment that's all I have to go on. And when you examine a hurricane system, they rotate around a central point, and the centre of these storms contains what they call the eye of the storm, and this is an area where the clouds are thinner and much lower than the other parts. When we look at the Jupiter image, we see a similar eye in the visible and ultraviolet images. Yet when we look at the infrared image, this central region is dark. Now surely this would be the thinnest part of the cloud and should show a clear hotspot. Also, why is there a banded structure that sits slightly above and slightly below the equator, which emit infrared radiation? And in fact, the one below seems to be in two bands and the one above in a single one. And again, this goes back to one of the episodes previously where we looked at the weather system and the fact that this weather system had a 7-year cycle, and it sort of cleared itself after the 7 years for 12 to 18 months and then came back. Again, what is driving that? It can't necessarily just be solar radiation that causes a 7-year cycle in the weather pattern. Now, another question is, was Jupiter always part of the solar system, or was it captured? If planets are also powered, how do they connect? As they sit inside the heliopause, which contains a double layer, they can no longer be attached to the external Birkeland current. Now, if we look at Jupiter, we also know it has its own Langmuir sheet, which shields it from the solar environment. If we look at Jürgen's model, then the Sun should be the most electron-deficient body in the solar system. This would mean that electrons from the planets could be drawn towards the Sun, and equally positive ions streaming away from the Sun would be drawn in towards the planet, and in that case they would be drawn in at the poles. Now, this connection would be very different to how stars are connected. So do we essentially consider the planets like large comets with a difference in potential, and that it is this difference that drives some of the electrical activity that we see on the surface? We see differential rotation at the poles of Jupiter, which might be evidence of a Birkeland current structure. But if this is simply due to infalling ions from the solar wind, again, the question is, how would they form such a complex Birkeland current structure in a relatively short distance? Now, we've seen evidence in the Waterbridge experiment that Birkeland currents potentially can be set up in very small distances. When we looked at stars, we consider stars to be a load in a circuit. The planets are different. We don't necessarily consider them to be a load in that circuit. Instead, they are considered bodies at a different potential to their surrounding, which then raises the question, how long would it take for them to reach neutrality or reach an equilibrium point with the surrounding environment? And what happens or changes when it does that, or when it approaches that? Or is there some mechanism by which the imbalance continues? Now, Jupiter, as we've talked about, shows very regular changes in the weather pattern around the equator every 7 years, and the clouds clear for a period of 12 to 18 months. Why does Jupiter emit more energy than it receives? Again, the mainstream model explains this through activity that goes on in the core. But again, if we're talking about an electrical process, how does that work? How is the very large magnetic field of Jupiter created? And again, important in this one for me is if we're considering this to be a difference in potential, that means that the current flows in at the poles in both directions. So you don't have, like in a circuit, you'd have in at the North Pole and out at the South Pole. If this is a lower potential point, that means it's going to stream in, and if the only gaps available are the poles, it will stream in at both the North and the South. Question is, from that flowing of current, how do you create the magnetic field that ends up being coherent? Now, obviously, you could argue in Jupiter's case, there is this weird anomaly that the magnetic field is changing. So that may have something to do with it. It could be to do with the flow within that internal structure. Again, what is that internal structure? As I slowly start to delve into the detail of the electric sun concept, it raises for me many questions about how the planets fit into this model. There are many questions and many different ideas about how to explain some of these phenomena. The key is understanding how this then connects back to the larger picture. This is something that I would like to explore in more detail in the near future. As always, be brave, be curious, the truth is waiting for us. Until next time.